When we talk about motion, we can classify it as uniform motion, non-uniform motion. Non-uniform motion is also called as accelerated motion. Under accelerated motion, we can further classify them as the motion as uniform acceleration and non-uniform acceleration. Under uniform motion, the classifications are rest and the object being at constant velocity. In rest, we can tell the object is at rest, at the origin and not at origin. So we'll be looking at all the different cases, the graph related to them. So we are beginning with actually I should change the values over here first. So we'll begin with the object being at rest at the origin. So here whatever I do for a given interval of time, if an object is at rest, it won't go anywhere. And so we have the following graph. With regarding to distance and time, it would be a line on the x-axis. Right, see, we can see the value 0 over here. It means it's on the x-axis. This too is a line on the x-axis. This is a displacement time graph. Velocity time graph, it's a line on the x-axis again. We can see it's on 0. And when it comes to acceleration time graph, it's a line on the x-axis. The acceleration is equal to 0. So this is a case wherein the object is at origin. Now, what if the object is not at origin, but it's at rest somewhere else? Say you're waiting for your friends and they tell that, okay, let's meet up over there. From there, we'll go to play. So you're waiting, not inside the house, but outside the house. Generally, house is considered as the origin. That is the point 0. And from there, you're not at 0, but you're a bit away. Say x unit away. So representing this on a displacement time graph, we have a graph like this. So that's time and this is displacement. And that's 0. This would be a graph something like this. Why? See, at 0, the person or you are at x units away. At 1 second, you are again at the same place. Any point of time till the point t seconds, you are at the same place. So displacement would be fixed. So this would be a linear graph. Linear means a line which is straight. And this would be non-zero because you're not at origin. And this would be parallel to x-axis. While your velocity and acceleration, they won't change. They will be 0 itself. So like this, they would be 0. Next is a case of uniform acceleration, if not non-zero velocity. Right? What does that mean? The object is moving. So something like this. Remember, this is uniform motion. So here we are looking at constant velocity. Okay, so we are looking at constant velocity, say a velocity of 50. So constant velocity will have a distance being covered to be equal. So you can look at pick any two random motions over there, they would be equal. So graphically, they would look something like this. So every 2 seconds, I can see they have moved 100 meters. Every 2 seconds, 100 meters. Every 2 seconds, 100 meters. You take every 1 second, it will be 50 meter. And so the velocity is 50 meter per second. That's what velocity means, right? How much distance are we covering per second? It's 50. While the acceleration will continue to be 0. The reason being, there is no change in velocity. Remember, acceleration is to do with change in velocity. And now to talk about the nature of the graph. We'll just talk about if it's linear or not. This is linear. What does it mean? It's a straight line. This is linear. This is linear, which is parallel to x-axis. Parallel to x-axis. And this is non-zero, that it has a value which can be either positive or negative. And this is 0. Because again, it's constant velocity, so there's no acceleration. Right? And now a case of non-uniform acceleration, that is accelerated motion, under that we are looking at uniform acceleration, and under that I'll just write it as type accelerated motion. Okay, we have one more type, that is deacceleration. So that's what I'm trying to distinguish. So under acceleration we are looking at increasing velocity. So what will happen? Let's see. So I have a velocity of say 10. Now I'm pressing on the gas, that is I'm trying to overtake someone. See what happens. Look at the first and the last. The first displacement and the last displacement. Are you able to make out? There is unequal distance being covered in equal interval of time. But there is a pattern to this. And that pattern is the velocity is constant and the acceleration is uniform. Okay, let me take this graph onto the screen and let me explain it over there. So this is accelerated motion, that is we are increasing the speed, right? So basically we are trying to overtake someone. Example, overtaking. So what happens with velocity? It keeps on increasing at a constant rate because it is uniform acceleration. So every 2 seconds it is of constant acceleration. So let me show it to you guys. That is the rate of change of velocity over there, and it is same anywhere. You take any 2 point, it would be same. While your acceleration is a non-zero value, right? This is linear. This is non-zero. And it is parallel to x-axis. Right? So something like this. This turns out to be linear and increasing. This is nothing but this would be non-linear. That's all we need to tell. Non-linear. And here the value of distance is increasing. I'll show that to you guys. So this is the slope from 0 to 2, right? If I take this anywhere along the line, anywhere above, that is somewhere over here, you can see it is short of it, is it not? The y component is less. This is the amount by which it is less. So this is a scenario wherein we are trying to overtake. What happens if we try to brake? What happens then? So let's have a look at that now. Let me cancel this. Let me make it 100, and we are going very fast, and then we're trying to brake. So I'm putting my brake. So what is happening? We are deaccelerating. How will the graph look? See, the distance is coming to a halt. The distance and displacement, they're becoming parallel to the x-axis, means it is reducing. Velocity is also almost, it became 0 over here. And we can see the acceleration graph from 1 to 5, it is linear and it is negative. right? So this is what you need to understand. This is a case wherein you are deaccelerating. Okay. So basically you're putting on the brakes. Right? So your velocity is decreasing, and basically this is non-linear, non-linear, this is linear, and this is also linear. Same thing, just that the values are negative. So here the value is negative and this is positive. Right? So this is positive and this would be negative. So this is your graphical representation of few of the cases of motion. You need to copy this and then this. Don't copy the values. Please don't copy the values. It won't be necessary. This is all random example. Don't waste your time by copying the values.